Thank you, Enrique. Now that we have listened to all these amazing talks on explainable AI, let's look at how we use and not use explainable AI for the Cinderella project. So, as you all may already know, this workshop is being held as part of the Cinderella project and was organized by the consortium of the Cinderella project. So now let's take a look. Okay, well, now let's take a look at the Cinderella project. So in the Cinderella project, our goal is to help breast cancer patients decide on their treatments. So there are many forms of treatment for breast cancer. For example, conservative treatment removes only a part of the breast that has the cancer. Mastectomies remove the entirety of the breast. Then these two types of surgery can be accompanied by reconstructive surgery to reconstruct the breasts after they have been removed. And there is also radiotherapy that is very common for breast cancer treatment. But all these forms of treatment alter the appearance of the breasts by causing asymmetries, scars, and color alterations. Because of these alterations that occur to the breasts, patients often have difficulties in choosing what treatment plan they should go for because they don't really know what to expect from each type of surgery. And because they don't know what to expect, patients often become disappointed in the outcomes of the treatment, which leads to lower self-esteem and lower quality of life after treatment. And in Cinderella, we want the patients to be able to make an informed decision of the treatment plan. And to do so, we are developing a web-based app that will help the patients make these decisions. And the idea of how it works is that before the surgery, the patient takes a picture of their breast and uploads it to the app, and the app will then predict how the patient may look like after treatment and shows that prediction to the patients. So behind this app, there are a few artificial intelligence tools that we have been developing. And we have been developing for two main tasks. The first is for predicting the aesthetic outcome of breast cancer treatment, where we want to generate an image that shows how the patient will look like after treatment. And the second task is evaluating the aesthetic outcome. So now let's look at how we are using explainable AI for the evaluation task. So aesthetic evaluation is a classification task. We want to assign a class between excellent, good, fair, or poor to an image that is post-surgery. In this case, it is incredibly important to have explainable AI to ensure that the model is focusing on clinically relevant features like asymmetries or scars, and that it is not focusing on features like the patient's weight or the size of the patient's breasts. So explainable AI helps us build models that are fair, that are not discriminatory, and that are trustworthy. So until now, we've heard a lot of explainable AI techniques, mostly for explaining deep learning tasks. However, in the Cinderella, we are not actually using an artificial neural network. We are not using deep learning. We are actually using an older technique, which is we first look at the images and we define some metrics, some manually defined features that we know are relevant for the prediction. In this case, for example, we know that the surgery treatment causes asymmetries, so we can look at the asymmetries in the breasts, and we can measure the distance between the breasts, and that will be the lower breast contour asymmetry metric. Then we can also see other differences in the shape of the breast and differences in the position of the nipples to calculate various sorts of metrics. So in the first step, we first transform an image into this tabular data. And then we actually devise a machine learning model that is actually a scorecard. And the way the decision process works is that we take the features of the patient and we have this lookup table where we try to locate for each feature where does the patient fit in the interval of values, and we assign points to the patients. And at the end, the total of points will be used to classify the image. In order to explain the prediction, we can simply go back to the lookup table and we can see which of these features have contributed the most to the prediction. For example, here the LBC, the lower breast contour feature, contributes with 58 out of the 72. It is the most important feature. So this is kind of a concept-based explanation. So this is for the aesthetic evaluation. Now let's look at the prediction of the aesthetic outcome. So the aesthetic outcome prediction is a slightly different task. Instead of a class, what we actually want to predict is an entire image. So up until now, in all the talks that we've had until now, you might have noticed that most of the explainable AI techniques have been developed for classification tasks or for regression tasks where the output of the model is something very small like a word or a number. However, and in fact, actually, we see that in the scientific literature, most of explainable AI has been developed for these tasks. But when we look at tasks like generative tasks, where we predict an entire image, we really don't see many explainable AI techniques. And perhaps the reason for that is because the model, by giving us an entire image, it gives us so much more information to the point that we don't actually need much of an explanation. For example, by comparing the postoperative prediction with a preoperative image, we can see that what changed here was the position and shape of the left breast. However, we don't really need a saliency map now to tell us that the AI model is focusing on the breast, because we can already infer that directly from the prediction. So the main takeaway is that explainable AI is not needed as much the higher the amount of information that the model provides. Nevertheless, it is still important to be able to explain this prediction to a patient. And I just want to clarify that for this task, we do not actually use any explainable AI technique. And instead, to explain the prediction, we can explain it based on the process that we take to get from the preoperative image up until the postoperative image. So in this case, what we do in Cinderella is, the first thing, we look at images from past patients that have gone through the same surgical procedure of the current patients. And we select the patient with the most similar breasts. Then what we do is we develop an AI generative model that will take the asymmetries of the past case and will transfer them into our preoperative image. And for the purposes of explaining to the patient, this may be sufficient. It may be sufficient to simply take the image from the past case and show the patient and say, well, the reason why we think you're going to look like the postoperative prediction is because you have similar breasts to this past patient who has also gone through the same surgical procedure and also looks similar to your prediction. So that could be an explanation, and perhaps that will suffice. But we could even go a little bit further and explain exactly how the AI model does this process of transferring asymmetries. For example, one of the models that we have developed has this reasoning where first we remove the breast that is being surgically altered from the image. We entirely remove it, and then we add some annotations of where the nipple is expected to go and also for the lowest point of the breast. And these annotations are made based on the symmetries that we take from the past case. And then what we do is we train an in-painting model, which will fill these missing regions based on the annotations that we provide. And for the computer scientists out there, this model is actually a generative adversarial network. So, some conclusions. The main takeaways from this talk is that explainable AI is incredibly important to develop fair and trustworthy models, and especially important for models that give us a low amount of information, like classification and regression tasks. There is also a way that we explain AI models, like generative models, without explicitly using explainable AI techniques, by explaining not the model, but the procedure that we implement to go from the input of the model up until the output. So with this, I finished the presentation. Thank you all very much.